my name is Rebecca Bowling, and I'm the director of the Drescher Center for the Humanities. And I'd like to welcome you to another Fall Humanities Forum event. And this is the last event of our 5-part C.P. Snow series commemorating the 50th anniversary of C.P. Snow's Reed Lecture at Cambridge University on the divide between the two cultures, the sciences and the humanities. So far in this series, we've talked about the lecture itself and the controversy it provoked, with talks from our UMBC faculty, Dr. Joe Todorevich and Dr. Rick Welsh. We then explored with 3 visiting scholars from the UK and California how we view science and expertise and authority in the last 3 lectures. Today we come back to conclude the series with a panel discussion with 4 current and former UMBC faculty about the connections between the sciences and the humanities. This series is sponsored by UMBC's Drescher Center for the Humanities, the Human Context of Science and Technology Program, and Social Sciences Forum. I'd like to introduce briefly all 4 of our panelists who will address the topic from the perspective of their own scholarly work. I'll introduce the panelists to you in the order in which they will be speaking, and we've seated them accordingly. First, Sue Dwyer, then Tim Topoleski, Christoph Irmscher, and finally Manil Suri. I will make these intros very brief so as not to cut into the time we have to hear from each of them in about 10 to 15 minutes, and to make sure we have time for discussion. So their presentations will be 10 to 15 minutes, not my introduction, don't worry. Dr. Susan Dwyer received her PhD in philosophy from MIT with a minor in linguistics. Before coming to UMBC in 1999 as chair of the philosophy department here, she taught at McGill University in Canada and the US Naval Academy. Last year, she transferred to UMCP, where she is now associate professor of philosophy. Her publications center on the topics of moral philosophy, philosophy and public policy, and feminist theory. We are thrilled to welcome her back to UMBC. Our second speaker today is Tim Topoleski, professor and graduate program director in UMBC's Department of Mechanical Engineering. And I should warn anyone, if you haven't updated your websites, you're getting late information. Indicative of how widely respected Dr. Topoleski is among students and faculty alike, he is currently both UMBC's presidential teaching professor and chair of UMBC's Faculty Senate. His PhD is in bioengineering from the University of Pennsylvania, and his research fields are biomechanics, solid mechanics and materials, and the fracture and fatigue of natural and biological materials. He is also a musician, and his team taught our humanities scholars in their first-year seminar with ancient studies professor, Dr. Jay Fryman. Our third panelist is Dr. Christoph Irmscher, professor of English, with a focus on 19th century American and Canadian literature and culture, in particular, nature writing. Dr. Irmscher received his PhD and Dr. Habil from the University of Bonn. He was here at UMBC from 2000 to 2006 and served as chair of the English department until he too transferred, in his case, to Indiana University. He has guest curated exhibits at the Lilly Library in Indiana on Longfellow and most recently on Darwin, which will soon open. Our fourth panelist is Dr. Manil Suri, professor of mathematics and statistics here at UMBC. He was born and raised in Mumbai, India, and obtained his PhD in applied mathematics from Carnegie Mellon University. He specializes in the field of numerical analysis and devises ways to bring mathematics to the public at large. Dr. Suri is also a novelist, the author of 2 best-selling novels, The Death of Vishnu and The Age of Shiva. The most successful of his popularizing projects is his presentation, Taming Infinity, which he even presented at the 2006 International Literature Festival in Berlin. So I think this gives you a sense of the range of the connections of science and humanities, even in our panel. So please join me in welcoming them. Just get up and start. Okay. I'm not a PC user, so I'll make sure that this works from the beginning. Okay. Right. Well, it's absolutely delightful to be back at UMBC to see so many friendly faces. I'm going to walk around a lot. This is how I do it. I'm sorry for the camera person. Okay.
So I'm a philosopher, and as you may know, the sort of joke is that philosophers do most of their work from their armchairs. My speciality, my research is on moral psychology. I'm going to talk a bit about that today. And if you don't know what the magnet is, it's that thing there. That's an MRI machine. Some of you may have spent some time in one of them. So this is moral psychology from the armchair to the magnet, as it's affectionately called by people who use them. So philosophers have been for centuries, I mean, part of the Platonic dialogues is indeed this, looking at moral judgment in naturalistic settings. And here's what I have in mind. Here are some unfortunately familiar photographs. These are photographs of Abu Ghraib that I'm sure you've seen before. And we imagine a moral agent. It's really not going to work, is it?
It's fine for the camera.
Okay, make sure everyone can see. We imagine a moral agent witnessing these things, right, in a naturalistic setting, and she makes a moral judgment. That's wrong. These are relatively automatic, surprisingly confident, and there is massive convergence. It seems like I talk about some of that research in the question period, if you want, amongst human beings. And then philosophers use that judgment, that those kinds of actions are morally wrong, as a data point, right, for testing the plausibility of certain theories about what makes actions right and wrong. More recently, we've been seeing the different use of moral judgment in so-called thought experiments. So now we have a different moral agent. I'm not going to comment on whether this moral agent is more sophisticated than the previous one. And I hope you can see these pictures. These are representations of what's known in the philosophy literature as the trolley problem. And some of you may have heard of this. So here's basically what's going on. The subject is told that of this situation, this trolley has lost its brakes. It is coming down this pathway on which there are 5 people who are unable to get off. You don't need to know who they are. You don't need to know why they can't get off. And on the spur, there's a single person. Again, you don't need to know why he's there, why he can't get off, or who he is. We imagine an agent here who has, just a person is all I mean by agent, who has access to a lever that will deflect the trolley from the path on which it's currently going to over here, right? And you ask subjects now in, relatively well-controlled experiments whether it is permissible for the person to pull the lever and run over the 1, thereby saving the 5, right? Everyone with me on that? This is what 89% of typical subjects say, right? It's morally okay. Some people think it's more than morally okay. Some people think you are positively obliged to turn the trolley, right? Good utilitarians amongst you will have done that. Over here, the trolley again has lost its brakes. Here is a bridge over the tracks. 5 people are trapped and can't get off. This used to be called the fat man case, but I'm not allowed to call it that anymore. This is the large individual case. There is a large individual on the bridge. We imagine a moral agent standing behind the large individual, and all she has to do is, and the large individual will topple off the bridge, and he or she is so large, they will stop the trolley before it gets to the 5, right? What do you reckon people say here? Not okay. This is a puzzle, and it has been a puzzle for philosophers since the 1970s, when the British philosopher Philippa Foot brought it to our attention. Because if it's okay to sacrifice 1 over here to save 5, why isn't it permissible to sacrifice 1 to save 5 over here? So this particular problem has now been appropriated by cognitive and developmental psychologists to try and get at what's really going on in moral judgment. If you think about moral psychology as a branch of cognitive science, not just armchair philosophy, right? And that's where my research is housed. If you want to do this yourself, if you want to participate in the gathering of data, here is the website. It's the Moral Sense Test, run by Mark Hauser, who's one of my collaborators at Harvard. We have a new paper just out in Mind and Language, and one coming out in Topics of Cognitive Science in about a month. So this is the question. This is the research question. What is the source and nature of moral judgment? Here are some armchair answers, right? Remember, I'm starting with the armchair. This is St. Thomas Aquinas, 13th century. Rough idea. This is very, very rough, okay? The divine being has inscribed natural law into our breasts, as it were, okay? So it's written, morality is written into human nature. We consult our conscience in order to determine what is right and wrong. That is the source and the nature of moral judgment. This is Francis Hutchinson, a little later on, who amongst with Adam Smith, David Hume and so on, central to the Scottish Enlightenment, the British sentimentalists, who said that there's a moral sense akin to a kind of perception that explains moral judgment, all right? So we literally just see things in the world, and then we have an emotional response to it and judge that it's right or wrong. And here's the big bad guy of the dead white guys of philosophy. That's Immanuel Kant, a little bit later. And for him, the source of moral judgment is rational being as such. Don't worry what that really means. Hardly anyone really knows what it means. But the idea is that morality is not, categorically not, a product of our affective or emotional lives, right? It is a product of reason. So big split here, right? What you lose from Aquinas to Hutchinson is God. What you lose from Hutchinson to Kant is affect or emotion, okay? And this really sets the stage for centuries of argument about the nature of moral judgment, done from the armchair. So let us ask the same question, now getting out of the armchair. Well, here are some things that animate my research. I take these things actually to be facts. Very odd to ever hear a philosopher say that she's asserting facts. One, all typical members of the species Homo sapiens sapiens do it. Typical members engage in moral judgment. Two, the capacity to make moral judgment emerges very early in human development, around about 2 3/4 years of age, actually. And there are lots of studies of this, cross-cultural studies with kids from different religious families and so on that back that up. And thirdly, while there's some moral diversity, there is remarkable convergence across the globe where the moral sense test has actually been taken into small villages as well as north and south on the planet, as it were. So if we take these to be facts, what are the implications then for how we ought to address the research question, right? Which notice is the same from the armchair as well as out. Well, I think that if you take it the universality of the capacity for moral judgment seriously, you've got to say that the capacity for moral judgment is biologically based and it's probably neurophysiologically realized, right? Haven't said anything specific, but that seems to be a fixed point. If you focus on the fact that the capacity for moral judgment comes online very, very early in a child's development, it suggests the capacity is innate. And this raises very interesting questions about what the relation between our moral capacities and other innate capacities are. So, for example, our capacity to be a speaker of a natural language. I am an unabashed Chomskyan, so I don't want to get into that argument. I think that that's innate. There's good evidence now to suggest that the 2 basic number systems are innate. And theory of mind might be a new term for you. It's basically the capacity to attribute beliefs and desires to other creatures, right? To see other creatures as minded in the way that you are. And thirdly, if you look at moral diversity and you take note of this massive convergence of moral judgment, this actually has a very direct impact on philosophy because it suggests that relativism is actually not borne out by the facts. Okay, so the seduction of reduction. If you're a philosopher who takes actual empirical facts and data seriously, you very, very easily get caught up, I think, in this seduction of reduction. What do I mean by that? Well, what I've done is suggested that there are 4 levels of analysis. There may be more. This is just illustrative, right? I'm not committing myself to any kind of ontological certainty here. We begin with philosophical analysis of moral judgments. We ask, is it reason or emotion that are their source? We might want to say what really matters for moral judgment. Is it the consequences, outcomes of actions that matter, or is it the intention of the agent when she acts that matters for whether an action is right or wrong? Those are the kinds of issues that you deal with at the level of philosophical analysis. What you're doing, in my view, is getting these questions into the right shape that you can pass them on to cognitive scientists and see what they make of those questions at that level of analysis. So now the question, is this an innate faculty, like other innate faculties we know something about, can be asked? And now the big debate is whether or not there's innate faculty for morality, or whether we just use a general purpose learning mechanism to acquire this capacity for moral judgment. It probably won't come as any surprise to you. That's what my book's about. Okay, cognitive scientists get questions into a certain shape, pass them on to the neuropsychologists, who ask different kinds of questions and supply supporting data, as it were, back up the chain. So there is a lot of work with so-called psychopaths. These are not axe murderers, but they are people who seem not to be motivated by moral considerations, but who don't suffer from any psychoses or neuroses. Autism spectrum disorder, again, a population that's really worth looking at for the purposes of trying to figure out, what the nature and source of human moral judgment is. Neuropsychologists now have the questions that began up here in a different kind of shape, a shape that makes them amenable for investigation by neuroscientists. And that's where the magnet comes in, right? We stick people in MRI machines and ask them to do those trolley problem cases, and we see which parts of the brain light up. And we try and figure out what the neural pathways are, for example, between the amygdala, which is heavily associated with emotion in humans, also seems to be involved in moral judgment, what the pathways between the amygdala and the neocortex are. So the idea is the questions may start with philosophy, but at every level, what inquirers are doing is getting the questions in the right kind of shape to let other people go to work on it. I think this is what John Locke, a philosopher who otherwise I really don't have terribly much time for, except his political philosophy, I think this is what he had in mind when he said that philosophy is the handmaiden of the sciences. Right? So here's a sampler of findings. There's obviously lots to say. Typical subjects do judge that it's morally okay, and I'm using that expression not permissible for a very important reason. Happy to answer questions about it. To sacrifice one for many as long as the one's death is not intended. That confirms long-standing philosophical intuitions about this, that it is permissible to sacrifice one to save a large number. Autism spectrum disorder children demonstrate age-appropriate moral judgment capacities, so they're making the same kinds of judgments as kids their own age who are not autistic, but the fundamental, one of the fundamental aspects of ASD is a lack of mind-reading capacities. So autistic kids are not able to actually attribute minds to others, which is what, at some very deep level, explains some of their social problems, their lack of affect, and so on. So this suggests that moral competence, the capacity to make moral judgments, is independent of a theory of mind. But that's a question we can now ask and answer. Sorry. Psychopaths, and the VMPFC stands for ventromedial prefrontal cortex. Patients like that who have damage to that area of their brain tend to be more utilitarian in their moral judgments. And this suggests that emotion plays a crucial role in typical moral judgment, because the VMPC patients also have very, very reduced affect. I love this because I can now email people and say that brain damage turns you into a utilitarian. Anyway, all right, take-home message. There's an admonition, and then there are two cautions. Here's the admonition. To the extent that a philosophical question makes assumptions about human beings, and when I say philosophical question, I don't just mean questions about morality. I mean questions in philosophy of biology, philosophy of physics, issues about human knowledge, issues about what kind of stuff there is in the universe, to the extent they make assumptions about human beings, namely members of biological species with a phylogenetic past who undergo ontogenetic development, sound inquiry positively requires that the philosopher pay attention to empirical evidence. Philosophy is about us, and those facts explain the kinds of beings that we are. So you've got to get out of your armchair sometimes. Here are the cautions. A priori philosophical claims, the claims you really do make in the privacy of your armchair without consulting the facts, they can be very risky because they tend to unduly constrain empirical inquiry or end up reifying problematic concepts. So if you just say, look, obviously utilitarianism is the right moral theory, that is going to infect all of your inquiry all the way down those different levels of inquiry. And when you get someone in the MRI machine, you're going to say, oh, there's the utilitarian part of the brain, which of course is utter nonsense. It's utter nonsense that's being published in Science, Nature, and I could go on. So the philosopher, I think, can help by articulating the appropriate explananda for cognitive science. That means getting the questions in the right shape, and so on down. The cognitive scientist can do it, again, for the neuropsychologist. Here are the take-home message caution number 2. Resist the seduction of hasty reduction. I do not believe that the mind is utterly independent of the brain. My slogan is no minds without brains, but they're not identical, all right? So you have to be really careful about hasty reduction. fMRI studies do provide very pretty pictures, and people like to publish them. But the current temporal and spatial resolution of fMRI is in the order of seconds and millimeters. That's vast when you're talking about the brain. So I still remain completely unconvinced about what, if anything, we're learning from sticking people in magnets and giving them trolley problem cases. Still, I'm fully committed to the overall research agenda, that there are these different levels. One can participate at any level, and there's a kind of feedback between them. I couldn't do my work without taking that really seriously. So, yep, I do get out of the armchair occasionally, but I get back into it in the summer, and at least I've taken my armchair outside. That's it.
So, I'm thinking, Rebecca asked me to talk about the connection between the sciences and the arts, and I think you hit upon the connection because there's utter nonsense being published in all of the journals that I read all the time as well. So, I think that's where we have, where we find the commonality. And this is your clicker? This way?
Yep.
So, I recognize that recently there was another anniversary. This is the 50th anniversary of C.P. Snow's The Two Culture. I read this in the paper, and about a week ago, it was the 497th anniversary of the completion of the Sistine Chapel by Michelangelo. And I want to point out to you, this is the restored Sistine Chapel. I want you to look at one thing. Look at the colors here. They're sort of reddish, greenish, flesh tones, pink. All right, that's going to be very important for something I'm going to bring up a little bit later. But before we get into the connection between the arts, humanities, sciences, technology, I thought I'd tell you a little bit about what I do. And in fact, in our lab, we look at both engineered materials and natural biological materials. We're looking to modify surfaces, prevent wear, and prevent fracture for materials that are going to go into people's body. And on the natural and biological side, I'm interested in how disease mechanics and microstructure, that is how the materials are created, combine, and how that affects tissue behavior. So the easy way to approach the question might be to ask, what do Van Gogh and Einstein have in common? And if we can draw a link between the two, then perhaps we can connect science to the art. But I think there's a better and more essential question to ask, and this is what I want to answer today, and that's, why is an apple tree like a violin? So I'm a violinist. It's one of the things I enjoy doing. And we'll get to this in a second. Now, if we're talking about the relationships between the humanities, arts, and the sciences, I had long talked to my colleague Jay Fryman about teaching a course to combine the two, and that finally came to fruition in 2003, where we talked about technology and leisure. And one of the things I would ask the students, if I may here, is what does this beauty and these are artificial hip joints, what do these have in common? Because I think there's a very direct link between these two. All right, so think about that. But in teaching this course, what we did was we explored how things work. That was the technological side. What we mean by leisure. And it's very interesting to think about what we really mean by leisure and how science and technology create leisure. And it got me thinking about a fundamental question about the students, and that is, why do most people avoid reading Les Miserables and Moby Dick? All right? Because Victor Hugo includes a history of the Paris sewers. And who the heck wants to read 20 pages about the Paris sewers, and they want to know what Jean Valjean is doing, right? And Herman Melville included descriptions of the natural history of the whale and description of the functioning of a whaleboat and the mechanics of whaling. And that got me thinking, well, if you think about the disciplines responsible for extending, improving the quality of human life, what would you say? And I would argue that you can make a good argument for two: civil engineers and agricultural engineers. Civil engineers are responsible for creating the sanitation systems that Victor Hugo writes about. And what does that do for us? It gives us bigger cities. There's a lot of advantages to that. Certainly less plague is good. And more time for the arts and culture. And the same way agricultural engineers created efficiency in husbandry. That's how we get after the whale. Allowing us also bigger cities, less field work, more time for the arts and leisure. Because if you think about it, none of us are worried about where we are going to get our food and whether our harvest is going to come in tonight. That's why we're here. And so we can look, that's a sort of a big picture. If we see that technology gives us time for leisure, but there are direct effects of science and technology on the humanities. And the example I want to bring in is Impressionism. And I learned about this at this particular Van Gogh exhibit, and I don't know if you can read it, it was 1994. But the Impressionistic revolution was really enabled by three things given to the artist by scientists and technologists. One is the design of collapsible chairs and easels. Before that, the painters couldn't get out into the field. If you look at the Impressionist paintings, now they're out in the field, they're looking at the harbors, they're no longer inside doing still lifes, right? Second, we could put paint in tubes. Very clever materials engineers came up with a way to put paint in tubes because before they were in big heavy vats, couldn't get them outside. But finally, the chemical engineers were able to stabilize the cobalt-based pigments. This is what gives us the blues and purples that you did not see in the Sistine Chapel. But you look here and you see Van Gogh completely surrounded by it. And if you go back and you look at the Impressionist paintings, so here we have a direct link between how scientists or technologists can provide tools for artists to use. And I want to go to, and I'm glad Robert DeLutti is here, and discuss a poem that he wrote, and which I use in a lot of classes. It's called In California. And it begins, tourists from Taiwan visiting a suburban mega mall study the registry. I should let you read it, Robert.
You sound much better.
67 fast food falls, 56 clothing boutiques, 32 electronics centers, 21 furniture dealers, 19 shoe stores, 11 jewelers, 8 bakeries, 7 hair salons, 6 ice cream parlors, 5 chocolatiers, 3 florists, 2 locksmiths, 1 bookstore. And we constantly talk about the cliche of living in a material world, but in fact we do. And look around you, you're touching materials now. And another direct effect science and technology can have on the arts and humanities is looking at the materials that are available to use. And recently I've been talking to an artist, David Hess, about material challenges he faces. And you probably know some of his work. This is at the AVAM. It's a bird's nest. This is called Baltimore Passage. It's down at the Inner Harbor. This, I believe, is called A Study of Momentum. It's in the rental car center at BWI. And this one is over there in Texas somewhere. It's not around here. So that's a little bit on how technology can affect the arts, but I think that we need to look a little bit deeper and look at the theme or themes that may connect the arts and humanities and science and technology. And I'm going to focus on just one, and that's creativity. We find creativity in both, but when we think about what creativity is, oftentimes to the person not an academic, it's associated with the arts and humanities, right? But, excuse me, George Dieter, who was my dean when I first came here down at College Park, wrote that we often think of a popular myth of creativity as coming in a flash of lightning. But he writes that, in fact, it doesn't. The creative ideas occur by a slow, deliberate process. They don't just happen overnight. And I first experienced this when I went to see this exhibit of Picasso and the Weeping Women. I'm not going to take you through these paintings, but I would urge you to go through and you can see how what we consider some of Picasso's greatest work came about by through a deliberate series of representations of his wife and his two mistresses at the time. And it's amazing to see how, even though the painting doesn't look maybe like anything representative at all, you can still see his wife baring his teeth at him when he's not in a good mood about her. But, so creativity, I believe, is invoked, provoked, evoked by our experiences, whether we're in the sciences or in the humanities, and I stole that from the Cirque du Soleil. So the question is, well, what kind of experiences do we have? You can have experiences, you know, bottom of a cave. This is very close, Luray Caverns. If you've never been there, I suggest you go there. Or halfway around the world when you get the opportunity to have a panda chew on your head, and I can guarantee you that this experience has changed the way I view life, whether it's reading a book or whether it is doing my work in the lab forever, right? And this is what motivates our creativity. So I wanted to give you a brief example of something that I think was particularly creative that we did in our lab. We're talking about material or mechanical failure of artificial joints, mostly done by my student Xu Lin. And artificial joints, if you don't know, are the most effective current treatment for arthritis. Essentially, we replace damaged cartilage with metals, plastics, or ceramics. And these materials are subjected to fatigue and wear, and their service environment, it leads them to fracture. Dealing with a material called bone cement, and these are actually radiographs of the artificial joints, similar to what I just showed you. This F is pointing to fracture. This material here, which is bone cement, it's really nothing more than plexiglass that we're able to put into the body, right? I want to find out why they're breaking, because when they break, you have to go in for another operation. So, how do we solve this problem? Well, the concept that we knew is that the sharper you put a notch into a material, the more likely it is to fracture. And that's why these were fracturing in people's bodies. Now, the challenge was, for various reasons, we couldn't cut a notch into our material to test how likely it was to fracture. We had to mold it, right? So my experience was, well, you know, I play the violin, and I know that smaller strings are used to create higher notes. We have different diameters of strings in violins and harps and pianos. And I asked my student, I said, mold your material around these different size strings, different diameters. The smaller the diameter, the sharper our notch is going to be, and the more likely we're going to get fracture. So how did we do it? Well, we needed to create a special mold. We really had to be able to place this string or wire where we wanted it, and we had to do it the same every time. See, scientists like things to be the same every time. That's one of the things we need to work around. So he created this mold, and essentially what we're doing is we're balancing a wire on the edge of a razor blade. And what it looks like is this. I want to sort of orient you. This picture is the original magnification is 1000x, right? The original magnification over here is about 1200 times. So we're looking at the original wire that made that hole was 22 micrometers in diameter. That's 1/5 the diameter of your hair. And yet he was able to put it right on the money, right? And now I know how to work with this. This is something I as a scientist can work with. But his creative solution was to be able to do this every time, and now I can watch cracks grow from these things, and this is the one that's eventually going to damage us. So this is a very creative solution. This is so small you can't really see it without an electron microscope, right? But we got to look at the big picture as well in my line of work. And I'm also a stamp collector, and I discovered this letter. It was written in 1877 by a man to his sisters, and what he says is, Sally, my beloved wife, departed this life of diseases of the heart. Now in 1877, he also writes that the love of my orphan boy is ... Now in 1877, a boy that might have been 16, 17, or 18 probably would not have been considered an orphan. They would have been out working. And so we may conservatively estimate that this young man that he was talking about was, what, 12, 14 years old. The woman, his mother, probably didn't get married. Well, she probably got married when she was 18 or 20, quite young. And so perhaps she died of these diseases of the heart when she was in her early to mid-30s, right? Quite tragic. And yet, in 2009, 132 years later, heart disease remains the primary cause of death in the Western world, right? And so, excuse me a second. Where have we come? And how do we solve this problem? We're going to need incredibly creative solutions to be able to keep people from dying of heart-related diseases. And in this summer, I gave a talk at Clemson called Creativity in the Human Aspect of Biomaterials Research, and I asked, can somebody who studies materials, physics, biomaterials, can we be considered a humanitarian? And the underlying question is, why do we do what we do? Why do scientists do what we do? Why do philosophers do what we do, historians, psychologists? And I think it's this, because people like to play violin, explore caves, spend time with their families, go bowling, visit the museum, eat too much, watch the ball game, snorkel. Even just saying the word snorkel is fun, right? If you can't get a joy out of that. And we don't want to know why our body hurts. We don't want to know why the hip replacement works. We don't need to know to enjoy a painting of Picasso or a painting of Mark Rothko's that these guys were really loony in the technical sense, or that they were hurting inside. We can enjoy it on its own. But we have to step back and ask, are we really making an impact? Why are we doing this? So I come back to my essential question. Why is an apple tree like a violin? And the answer is this, I think. Whether you're playing a classical concert, and Tan Dunn, as you know, is a modern composer, or you're doing some Irish fiddling with one of the icons of Irish fiddling, the violin works the same way. It's the same instrument. Very briefly, it works by resonance of the string. When you brush the bow across the string, it must sound the note. It has no other choice, because that's what we call the resonance frequency in physics. And you change the resonance frequency by changing the length of the string. Right? Very simple explanation of a violin. How does that relate to the apple tree? Well, people at Cornell University realized that apples are different when they're ripe from when they're not ripe. And they created a machine that actually will grab onto an apple tree, and they understood that the stems of the apple work very much like a violin. Depending on how old the apple is, those stems will resonate at different frequencies. And what they can do is grab the apple tree, shake the heck out of it at the right frequency, and only the ripe apples will drop off the tree because they'll be shaken and the green apples won't. And if you look at this is it grabbing onto the tree. All you see are green apples here and red apples on the ground. Somebody was really thinking, in my opinion, to be able to relate the fundamental theories of music to picking apples. That's a connection that we find between the arts and the sciences and creativity, which brings to mind a second essential question. Did Newton play the violin? And if he was fiddling under the apple tree, maybe that would have changed things. I don't know. I really don't know. But we do know that Einstein and Thomas Jefferson, for example, played the violin. And I believe that they did so because they know the same creative processes are required to understand the mysteries of the universe and to create new countries. It all is the same thing. And so I would leave you with these thoughts that creativity is common to both cultures. It is essential for both cultures. It is hard work in either culture. And we can learn from the so-called other cultures when we're talking about creativity, and we should learn from the other cultures. So, thank you.
I have a story about Einstein. Einstein, before he left for the United States, he played the violin at a gathering, which also included, at the time, a famous writer of comedies, Erwin von Horvath. Every time Einstein made a mistake, Horvath laughed outrageously, slapping his thighs, and Einstein's answer finally was, because he just couldn't stand it anymore, he said, "Mr. Horvath, I never laugh when I attend one of your comedies." And so this is just remembered that story. I'm a historian of literature, and with an interest in nature writing, natural history, and I think my justification for being here is that I have an affiliate appointment in history of science in Bloomington, so I occasionally teach the kinds of classes that no one else wants to teach, because the department in my department, history and philosophy of science, they're all philosophers, so they don't really want to deal with the historical stuff so much. I have an ongoing interest in Audubon, and I've just finished writing a book about Louis Agassiz, who was at one point the most famous 19th century scientist, and was in the news a little bit because of the Darwin bicentennial. He was Darwin's great adversary. I believe that Snow is right when he argues that the polarization between the sciences, between the two cultures, between science and the arts, has been a creative loss. And I also believe that literary critics are at fault to some extent for this. We've perpetuated this divide, I think, in two ways, by A, embracing and sharing cheerfully the scientific illiteracy that we share with the culture at large, and also by continuing to embrace a kind of emphatic concept of literature, the major writers that we need to study, who have answers to the enduring questions. Enduring questions is an NEH category. You can get an award for proposing a class on an enduring question. I see little reason to repeat C.P. Snow's withering comments about the scientists who've tried a bit of Dickens. That's what he quotes in the two cultures. And other than that, don't read. That's their business. But my business are my colleagues. And I see a similar scenario. I serve on my university's tenure committee currently, and I see a similar scenario play out every week, week after week. Whenever a scientist comes up with a tenure bid, none of my humanist colleagues have read the proposal very well. If it's mathematical formulas, they never get beyond the first page. And it's always a little embarrassing to me to see how the other scientists on the committee, biochemists for instance, they're able to explain what the physicist is doing in sort of general terms. The biologist can explain what the chemist is doing. When it comes to proposals from the humanities or projects from the humanities, it's always a little embarrassing to see that my colleagues, myself included, are not always able to explain what precisely it is that our colleagues in the humanities are pursuing. Here's an example. It's not from a recent case, but a candidate was describing his project in the following terms. He was arguing that, and I quote, "Cultural inscriptions of form in the generally available medium of meaning feed back into the availability of that medium, thus becoming relevant for the emergence of system-specific horizons of meaning in different interpretive communities." The scientists laugh when project descriptions like that come up. The only time we as humanists get to laugh when a scientist works on something like charismatic beetles, for instance. This was a recent example. And we know what charisma is, so we feel entitled to laugh about that. A 2009 survey conducted by the Pew Research Center and the American Association for the Advancement of Science revealed that only 52% of Americans knew why stem cells differ from other kinds of cells, and that just 46% of those polled were aware that atoms are larger than electrons. Now here's my proposal. Why not try, and this is directed to my colleagues in the humanities, why not try our hands at some different materials, at some different texts? Instead of writing for the umpteenth time about, or teaching for that matter, about Herman Melville or Toni Morrison, let's read someone like Henry James Clark. If you haven't heard of him, you don't need to worry. He wasn't prominent even in his own time. Some contemporaries knew about him because of his teacher, Louis Agassiz, featured here. Louis Agassiz thought he was the greatest living American microscopist. And at least that's what he said before he kicked Clark out of his museum. He fired him because Clark had become too good for him, and he just couldn't stand having him around anymore. And that's the long story. I won't go into the details. My new book, Mr. Agassiz's Puzzle Box, tells that story in one chapter. During the day, Clark would cut up jellyfish in Agassiz's museum or draw beautiful images of the eggs of turtles. Here's an example of creativity. At night, he would read Voltaire or go to the opera or to the theater, experiences recorded in rapturous language in his journal. And a fair amount of that rapture spilled over into his writing as well. One of his books, Lucernari and the Allies, deals with a group of jellyfish. Little jellyfish, not the spectacular ones that most of his colleagues were interested in. And what he's interested in this book, really, what he writes about most, is individuality. For him, this is not a given. It's an aspiration, something that one has to strive for. These are very, very curious animals, the jellyfish. They spend most of their lives in sedentary fashion, attached to seaweed or eelgrass by a kind of secretion. They use their tentacles around the mouth to capture small prey, small bivalves, snails, brittle stars, crustaceans. And once it's consumed these organisms, it spits out the shells. As immobile as these jellyfish seem in nature, confinement by humans will not suit them. And I quote from Clark's book. And I'm using this as an example of the kind of writing that maybe we should become interested in. It will appear to the inexperienced eye to be perfectly and fully well expanded for 3, 4, or 5 days after capture. But during all this time, it is quietly exfoliating its epidermis, both externally and internally, and finally indicates its illness in the extreme by falling from its attachment and lying inactively at the bottom of the aquarium, contracted and rolled up into a shapeless mass. To me, that is a beautiful sentence, evoking as it does Clark's privileged understanding of animals that won't reveal themselves to uninitiated people, to people who haven't studied them, until it's too late and they're dead. If you think, Clark is saying, that the Haliclistus, and this is the name of these jellyfish, held prisoner by a blade of grass in nature, can easily be transferred to the aquarium, which is sort of the Victorian epitome of nature and captivity, think again. They might deceive you for as many as 5 days, looking healthy and well on the outside, and look how he sort of increases the period of time, 3, 4, or 5 days after capture. During that time, the naturalist's experienced eye, and I like Clark's, and as we read this, our eye becomes kind of experienced as well, will know what's really going on. The carefully chosen adverb quietly in that sentence indicates or skirts, I would say, the limits of scientific observation, as does the description of the Lucernarius condition as illness when we capture it. Clark stops short of anthropomorphizing the animal, but he seems to be suggesting that there's purpose behind this disintegration, a determined refusal to enter into communion with the ordinary observer. The Haliclistus is a very delicate creature. Its body to Clark looks like the upturned small umbrella of a lady, he says. It's one way of thinking about it. Or maybe it looks, he says, like a fruit bowl, shallow, an 8-sided fruit dish, resting on a slender stem. But really, he says, viewed in a natural watery world, the opalescent play of varied intensity, and that's a quote from Clark, on the bodies of these little creatures, ranging from blue, green, or olive, to pink and violet, is hard to convey in language. This is a scientist, a microscopist, who thinks very, very carefully about the nuances in his prose. He doesn't aim to write poetry here. There's plenty of technical language in the book. There are words like proboscideal or flabelliform, for example. His science is good. He knows what he's doing. But so, I would argue, is the writing. A pleasure we deprive ourselves of as literary critics if we continue to believe with Emily Dickinson that if we reckon anything at all, we should always reckon poets first. That's one of the things she says in her poetry. More precisely, I would argue that we could still reckon poets first, but include a whole lot of other folks in that category. Some of these might just be scientists. Thank you.
Reference point for
Now I
Yeah.
can use it.
Okay, so it's very interesting because I actually was in high school when we had an excerpt from, was either C.P. Snow's really famous essay or some other writing of his, and that's when I first heard about him. And one of the things that he said was the kind of criticism that you mentioned in your talk, and went both ways. He also said something to the effect that what he expected people in the arts and humanities to know about mathematics in particular. Like, what's the equivalent question to can you read? And it was like, do you know what, I think he said calculus or some level up there. But the problem is that it's not so easy. And what I'm going to talk about now is why there is, is there this animus on the part of people who don't know about math? No, it's just that there is a problem with really integrating math into, popular discourse. I mean, math is a hard subject. So I'm going to talk a little bit about why there is this problem. Why do people on one side, on one culture, not know about the other as it pertains to math? So how does one actually motivate a math talk? And here are two quotes that'll actually set the stage. First one is from a former editor of the science section of the New York Times. And what he points out is that math has no emotional impact. So that's the kind of thing that he really pinpoints. That's why it's not popular. And he goes on to say that even physics, has these things, like physics is full of controversies, like evolution or other kinds of science are full of controversy that make these things more in the public media, but not math. And then this second quote is by someone, a mathematician, who actually was at NPR for a year, and he found that there were very few math stories in the media. And why was that? Well, someone told him that, okay, one can, you can recognize an atom, you can identify with things in other sciences, but something like a matrix or something that's abstract, that's very hard to really get your mind around. Okay, so here are the kind of approaches, that's all I'm going to talk about, the approaches that don't work for taking math to adult audiences or child audiences. And the first approach, and get ready for some sound effects, is what I call the shock and awe approach. And here the idea is that the reason you have to know about mathematics is that it's so useful that without it, you won't have planes or computers or architecture, you name it, energy, you won't have radio, you won't have anything. And so therefore, you have to listen to me when I talk about math. And of course, the reaction to that is, and as a teacher, as a professor, what I feel like saying at that point is no cell phone or Facebook either. Because the kids are always doing that under the table. So that's the first approach. Second thing is what I call the pennies in heaven approach. And this works very well for kids. It's often tried with kids. It doesn't work very well, it just is tried with kids. The idea there is that, okay, you're in a class of young impressionable minds and you say, okay, you don't need it now, but you will later. And if you study this equation, you can actually see your future opening up. In fact, there it is right now, opening up in front of your eyes. And of course the reaction, same reaction. So that doesn't work very well either. This is the sort of third approach. And this kind of stuff you will often see, even in the New York Times, where they'll take something like a cell phone perhaps, or a stereo or something, take it apart, and really show you how this thing works. What is the math behind it? If there's a mathematician involved, pretty soon there'll be all sorts of technical terms creeping in, like sine functions to really describe how these waves go, talk about the wave equation, and pretty soon there'll be something completely incomprehensible on the board. And as the mathematician or the scientist or whatever is babbling on, talking about electricity and all that, people will be running, screaming from the room. So that doesn't work too well either. And I should just say, one of the nice quotes is, again, from that Rob Feiner article, that for most people, they just want to use a cell phone. They don't really care about how it works. So that's the kind of problem. So this is what I call the macho approach. And here the idea is that you impress upon people just how wonderful a subject math is and how tough it is. In other words, it toughens up your brain, that its purity is completely unmatched. I mean, it's the most abstract thing. This, incidentally, was over Plato's Academy. And for a while, I believe it was also the slogan of the American Math Society, that you have to really know stuff to be able to enter here, to be worthy of this. And then, of course, there is G.H. Hardy, who wrote the famous book, Mathematician's Apology. And the one thing he doesn't do in it is apologize. He says that he likes math for two reasons. One is that it's very difficult. And secondly, that he really likes pure math, which has no applications. It's useless. And fortunately, that's not the way the current world works, that really it is applied math that you find in more and more fields. That's math anxiety, the two streams. This next approach is what I call the New Age approach. And you will often see something like, well, I'll just, So you can get really carried away with this. I mean, I've seen some, I was actually at a reading or something, and I picked up some book, and I saw that Deepak Chopra had actually used quantum physics to prove the existence of the soul. And now that can't be done, so you're supposed to laugh when I say that. So it's all these things, mumbo jumbo, spiritual stuff. Gödel's incompleteness theorem usually finds its way in there. So that's not a very good approach. This person, Apostolos Doxiadis, he actually wrote this book, Uncle Petros and Goldbach's Conjecture. And of course, the movie Pi, Beautiful Mind, Proof. Has anyone read or seen any of these? Seen all three, perhaps? Okay, what's common with the movies?
These are tortured souls.
Okay, that's a more harsh way of putting it. Crazy, yes. There's a mathematician in all of these works, and the mathematician always goes crazy. And that's one of the stereotypes in Hollywood, that, okay, if you put a mathematician in a story, he has to go crazy. There's a great say, there's the rule by Chekhov, if you have a gun in a play, it must go off. And the corollary is that if there's a mathematician in a story, he must go mad. So that's unfortunately one of the things we are seeing in the popular media. I should just say that I was actually giving a talk in Mumbai about 2 years ago, or a year back. And I told them I'm going to talk about infinity. They said that, their public isn't really ready for a very mathematical talk, and could I leaven it with something, something more touchy-feely, something more user-friendly. They gave me a list of things I should put into my talk, and this was the actual verbatim third thing that they asked me to talk about. And I told them that I haven't gone mad yet, but it didn't come up, so. At this point, I'll just, plug a couple of things that are on the web, on YouTube. One of them was something that we did at UMBC as part of a first-year project, first-year seminar project. And there were some visual artists in there too. And it was something where infinity is, you know, I think Rebecca was mentioning it. I actually made a trailer of that so that you'll go into YouTube and look for it. But it was really helpful to have this input from non-mathematicians. And there's some really great so the special effects is in particular. So anyway, that's available on YouTube. And I should say this summer, Michelle Oshiro and I, we had a nice collaboration where she was the dramaturge for, the sound is missing, for this play Arcadia by Tom Stoppard, which has a lot of math in it, fractals and so on. And so we collaborated on actually putting together a few things that could be shown before the play. And this is also on YouTube, so you can also look at that. And it kind of bridges the two fields. And this is the final kind of plug, and that is the Trojan horse approach. And this is usually, I usually give this talk right after this. This is the introduction to this talk. It really looks at some similarities between mathematics and fiction. So this is something else that, if you're interested, you know, it's on YouTube. Just to leave you with a couple of final thoughts, and then I'll stop. What can be done about this? You know, how does one promote this? It would be nice if there was some real collaboration in terms of grant proposals, which could be done between scientists, mathematicians, and creative artists or humanities persons. One of the real problems is that the NEA and the NEH rarely talk to the NSF, from what I understand. So that's a real problem there. And finally, there's also a large amount of money and resources being put into K-12 education, STEM education. One of the interesting things would be to combine all these things rather than have separate things for math and separate things for writing and reading. So anyway, I'll stop there. Thank you.
I think we've heard a lot about the interconnectedness between science and humanities, and I think our panelists are willing to take questions or willing to, we're all willing to hear about your thoughts about how science and humanities are interconnected and how we need to bridge those fields in order to really have a better understanding of each of them. So, questions?
Well, I have one. No, I enjoyed the presentation about the arts and science and some other people, Darcy
Perhaps
Thompson.
you can stand up so your voice
Okay.
carries a little bit.
Actually, Robert Provine, psychology. Enjoyed the presentation about arts and science. And some interesting cases there would be Darcy Thompson, Ramonica Hall. There's another number of these people that wrote the way that you're talking about there. And I think a real challenge is the relative inaccessibility of a lot of scientific topics. But I think the neglect or resistance of the arts and humanities by science is probably less than what you would find in the other direction. And fortunately, this is changing, although it's, I think, different than the history of these disciplines. You know, you have a Leonardo, you know, what was he, a technologist, an artist, a scientist. You know, we have, particularly I think in performing arts, you almost have people defining themselves by what they're not. For example, a performing artist might define themselves as a performing artist to show they're really serious by, you know, almost wearing their ignorance of science like a crown. What scientist would ever be proud of the, you know, this and the other, in the other direction? But it's a challenging issue. It's how do you resolve this? And I think the kind of things that you were talking about, you know, are interesting, you know, paths where clearly I think science is not lacking in the arts you know, if you know where to look and so on. Also, a step toward resolving, I think, some of these issues. Actually, I participate in a website called, actually it's called the Third Culture website. It's Edge. I don't know if you've ever come across Edge. But basically, it's an attempt to try, you know, to deal with these kind of things. It has both artists as well as scientists contributing to it, but it's an ongoing challenge. And I think one of the challenges is that an advantage that the sciences have is you can actually pose problems, resolve them, and move on. And I think very often in philosophy and the humanities, sometimes you can get caught up in the dialectics. You know, can you move forward, or is the day simply carried by a person that's more effective dialectician? You know, and it's always a challenge. I think at least science is free of that particular dimension of it. But no, it's intriguing position. I particularly enjoyed, you know, all the presentations here today. But also the Edge website, you know, something you might want to examine as a place where these are taken seriously and say, well, what do you do next, and what does that look like? But yeah, very nice all around.
Something that has always kind of gotten me is that I know there's a lot of collaboration that's attempted between arts and the humanities, but I feel like even at the student level, there's almost an animosity between them. Like, you know, a student may say, well, they may work hard, but they don't have to stay up late writing essays, or they may work hard, but they don't have to do higher math and things like that. And it's especially difficult for me because I'm one of both. I'm in the sciences and I'm in the humanities. So what would you say, do you think this is possibly kind of a problem, that people may have incorrect perceptions of disciplines not their own? And is there something we can do to resolve that, do you think? Or am I just having my own perception? I'm not sure.
Well, I certainly don't think it's a misperception. I guess my own view is that it's because the faculty who are educating you grew up with those same misperceptions. And I think that at least in my own field, and I mean, you know, philosophy is the quintessential armchair discipline, right? That's just not true anymore. And so I'm hoping that graduate schools will be spitting out professors of philosophy, right, who know a bit more about, you know, other areas in the academy. And so one can only hope, I think that this kind of thing has to, not evolve, it's a misuse of the word, this kind of change, I think, is affected, right, through actual people teaching different things. And so we need to be doing something different at the graduate student level of education, I think. It's going to take a while. We'll be out of here before then.
I think there are two things that go on. On the one hand, there is this, what I said, this macho approach, which I've seen, you know, different faculty members have, not just at UMBC, but other places too, especially in the math and sciences, where you really have to concentrate on one thing. And if you don't, if you have other interests, then that's a sign of weakness almost. Maybe you aren't spending that time writing grant proposals or whatever. So that's one aspect that I've personally seen. And the other aspect, I think, is the sort of math anxiety, that kind of thing that comes up with the people on the other side, perhaps, where there's a problem, there's some difficulty, and then one reaction is to, you know, be against that.
I can give you an example of what I've done. As I tried to indicate in my talk, I like using these kind of liminal figures, you know, artists who are also maybe scientists, or scientists who are artists. And I taught and this was funded by the NEH, I taught a summer course on Audubon at Indiana University. We have the Birds of America, that large double elephant folio, so there was a convenient excuse. And the NEH funded 4 weeks of summer instruction for school teachers from all over the states. And we had biology teachers, we had English teachers, history, art history, we had some practicing artists. And, you know, and this is a group that usually doesn't really go to, at least in that mixed form, they don't go to NEH summer courses, but we did get them together, and I had biologists who helped me teach it. Interestingly, art historians really didn't know what to do with this so much, because, you know, what is Audubon? Is it illustration? is it real art? They just couldn't really figure out what, and it's still, in terms of the scholarship on Audubon, you find very few humanists working on this, but the biologists were really interested in this, and I could tell them a couple of things. They, on the other hand, could help me, you know, with things that I didn't know anything about. And we are going to do this again, and this time I was the first time, I mean, if you get funded, of course, you have to reapply. The first time I was the only director, and one of the biologists who actually is a research professor at Indiana University has offered to co-direct it with me. So this is one way of getting sort of into the NEH a little bit and changing a couple of things about how they do it. I mean, these are incremental differences, of course, but it's something that at least I can do. I know how to write these types of grants. I can't change, you know, I can't shake up, rock the foundations of interdisciplinarity as we know it, but, you know, in these little ways, I think I can make a difference.
I thought there was someone behind you, but it's all right. Go. Yes.
I have a question for Dr. Dwyer. You talked about the reduction of philosophy to neuroscience, and I think that as somebody who studies philosophy, part of my fear of that reduction is that my explanatory claim is going to get preempted by neuroscience. I guess I'm just curious about your comments on that.
Okay, did everyone hear the question? That a philosopher might be anxious that their claim to provide any explanations of anything might be diminished if we actually see a reduction of philosophy to neuroscience. Did I get that right? It's never going to happen. And it's never going to happen in my lifetime. It's not going to happen in my lifetime. It won't happen in your lifetime. In fact, for me, I had to make a decision in 1985 about whether I was going to study minds or brains, because my undergraduate double major was neurophysiology and philosophy, right? And I figured I'd have more chance making progress in the mind part than the brain part. But here's, so one point is that we're so far from really understanding how the brain works that, as I said, you know, it's going to, whether the reduction ever happens before the heat death of the universe, I don't know. The second point is that members of our species won't stand for it. And you know, the typical philosopher's example here is that I see you standing at BWI, you know, and you're drumming your fingers and you're looking around and everything. What's your name? Matt. And someone says, why is Matt at BWI drumming his fingers, right? Now, if I was a very, very, very smart neuroscientist of the future, I could say, well, you know, the EPR is so-and-so, and the N600 is something or the other, and, you know, the amygdala's wobbling around in this way, or, I mean, it'd be much more sophisticated than that. And you'd go, huh? Because the kind of explanation that human beings require and expect from one another is couched in language at a different level, right? So the right kind of explanation would be, well, Matt got a call from his best friend who's flying in from the West Coast, and he's worried that he got there late and that he's missed him, right? Notice that that's adverting to what we would call psychological states, not neurophysiological ones. And so unless our species changes dramatically in the expectations we have of one another and the way in which we render the world intelligible to ourselves and to one another, you don't have to worry. We've been doing this for 2,500 years, Matt. You know, you have a future in philosophy. Any other? David?
Yeah, I think all four of you could be seen sort of making the case for interdisciplinarity. And I wouldn't be up here this afternoon if I didn't find it somewhat appealing. I think you've only good cases, but I'm wondering what if you could say more. I mean, I think one of the issues in the two culture divide is the problems with interdisciplinarity. So it's very difficult to do. You are all very talented people and can do it very well, but there are the issues of there's a case to be made for specialization in it. My own field is economics. It comes to mind with Christoph Irmscher's talk, where you say that literary critics and so on should be getting to areas outside of literature. Well, I've encountered some of the new economic critics getting into this, and some of them actually take great pride in really not knowing anything about economics. I mean, they explicitly say that, but then they go off and write 400-page books about it. And there's this issue of, So you know, I wonder if you could address sort of this issue of the other side of it, the sort of advantages of specialization and some of the problems encountered when one doesn't respect the differences in disciplines.
It's a slippery slope, and I'm not arguing that we should get into that we should sort of enter a culture of amateurism, basically, for the sake of better understanding each other. You know, that's of course absurd, but the alternative would be not to do anything about it, which is pretty much what the humanities, at least the ones sort of in my area, have been content with, because there's very few people who work sort of at the edges of the discipline as I do, because I don't have that many interlocutors, at least in my field, which is an advantage, but in some ways, when it comes to grant proposals, but it's probably not the ideal state of things. So I think it's a matter of defining on a case-by-case basis how far you can go and how far you can know about something, but it's better than not trying at all. And of course, what I admire about the scientists I work with is the fact how they can talk the specialized stuff, but then are able, at least the ones that I work with, are able to sort of communicate the essentials of it to someone like me. And I don't see that we in the humanities are always as good about that, which is sometimes very surprising to scientists who say, I mean, your business is language, you should be able to explain what you're doing in 1 or 2 or 3 sentences, right? There's one part of me that rebels against that, is why should I be able to do this? But of course, you know, then I think, wait a minute, language is indeed my area, I should be able to do it. So I don't know if that answers your question. It's sort of a matter of degree, I'd say. I mean, I'm advocating that we at least try to understand what we can. And in my case, the life sciences are a little more accessible to me than other types of sciences. And I do what I can, but of course I'm not arguing that we do away with specialization, which is necessary. It's necessary for advancement, it's necessary in the humanities, it's necessary in the sciences as well.
Oh, can I just say one thing? So David, if you really want to see the dangers of integration, check out what's called XPhi. This is experimental philosophy. It is a blight on the academic landscape.
Yes. I'm a PhD student here at UMBC in an interdisciplinary program, actually. And defending my proposal, I kind of like experienced this tension between the hard sciences and the humanities. And in our program, we're all the time mixing and matching very different fields. I have a specific question for you. What things do you think could be done for start pushing for more interdisciplinary activity in grad school specifically?
I think one of the themes that I've found both I go to a lot of medical conferences, and I find this in the life sciences a lot. They'll put up what we in engineering used to call a schematic, and they'll say, well, I've got this cartoon, and very demeaning, which is, it's a pictorial representation of what they're doing. It's beautiful. I mean, there's the green one, there's the red one, they come together, they die. Oh, it's really easy to see. And yet they take this demeaning tone, like this is so simple that I don't even want to talk about it. And I think we in the sciences need to do a better job of being able to talk to our colleagues and say, well, this is what I'm doing in language that is context for both. You know, I can start talking, or Manil can start talking in mathematics, and if you don't know the mathematics, you're not going to get it no matter how much we raise our voices and yell, right? We have to find common language, common context. And with your fellow students, that might be your first goal. To say, okay, what do we really know? Can you draw me a picture of what you're doing? This is what my first graders and third graders do, right? They like to draw pictures of what they're doing, and you know, they may not have the words, but they can communicate to me very successfully some of their ideas. Maybe we need to go to that level. But I think, you know, sometimes scientists have to get off their high horse and say, you know, yeah, my work is great, but I think I can explain it to you. I think I can put it in a way that you would understand it, and maybe enjoy it, and maybe even contribute to it. That's my.
You mentioned that you
you explain what you mean by liminal in the sense that you're using?
Something that, a topic or a pressing issue that really lends itself well to an integrative approach.
Oh,
Well, yeah, arthritis, for example.
moral judgment.
Or arthritis.
Or arthritis.
Well, what's very interesting is for arthritis is that there's a physical pain component, but there's also a very strong emotional component, especially in juvenile arthritis patients, kids. And kids cope much better than adults. And part of dealing with the disease is dealing with the part that worries about what the disease is going to do to the patient. And I'm not a psychologist, obviously, but I've learned a lot more about that aspect of it. And so, you know, there's got to be communication between the physicians, the psychologists, the patients, and then the people with the technology to try to help everybody work on it. I've seen this happen. It's actually quite fascinating.
My question, I guess, is spawned by Christoph's being rather critical of folks in the humanities, and also the question that was asked about interdisciplinarity with the hard sciences and the humanities. I'm from psychology, so I'm familiar with more of the soft sciences. And what I find amongst academic psychologists is that certain types of interdisciplinarity are very much fostered, very much valued, while other types of interdisciplinarity are not. So, for example, because I would argue, perhaps some of my fellow psychologists would differ, but I feel that many academic psychologists have inferiority complexes, and they're terribly concerned that they're not seen as hard enough, tough enough, empirical enough. And therefore, if there's interdisciplinarity between a psychologist and a biologist, a chemist, a physicist, all the better. But God forbid, if a psychologist should get too involved in the humanities or the arts, they are looked upon as being very suspect. They're trying to soften something that is already pretty soft. And I wish that sort of mindset would dissipate. And I think some wonderful interdisciplinary work between the so-called soft sciences and the humanities and arts would flourish.
Anyone else? Well, I think this is a wonderful end, and in some ways beginning, to our topic of the sciences and the humanities and their interconnectedness. And I want to thank the panel for being here. And I want to thank you for bearing with us. And I hope that this discussion continues. We have a little reception in the back, and please feel free to continue the discussion. Thank you very much.